Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Roman Architecture by Scruffamuda. And here are the rules. Normal Sudoku rules apply for the 9 by 9 grid. So that means we have to place the digits 1 through 9 without repeats in every row, column, and box, which is delineated by the darkened black lines. Skyscraper. Each digit in the 9 by 9 grid represents the height of a building in its cell. Taller buildings obstruct the view of shorter ones behind them. Cells outside the grid must contain the digit equal to the number of buildings visible from that vantage point in the adjacent row or column. So, for example, if this were, I don't know, we're just going to make a random one. Say this was, well, let's just make a random one. 3, 5, 2, 7, 6, 1, 4, 8, and 9, right? If we looked at it this way, this would have to be 5 because it sees the 3, it sees the 5. It does not see the 2 because that's blocked by the 3 or the 5. It sees the 7, but it does not see the 6 because the 6 is blocked by the 7. It doesn't see the 1, obviously it doesn't see the 4. And it sees the 8 and the 9. So it sees 5 skyscrapers if we look this direction. Now if we look this direction, this would be 1 because it only sees the 9 and it never sees any other building behind the 9, right? Because the 9 is the tallest building. And that's how skyscrapers work. We also have XV. Digits joined by an X sum to 10. Digits joined by a V sum to 5. All possible X's and V's are marked. So that is a negative constraint there. So we know that if it's in the puzzle somewhere, actually anywhere in this puzzle, and it does not have a V or an X next to it, in between two cells, those two cells cannot add up to 5 or 10 unless you have an X or a V between two cells. Two adjacent cells, shall we say, the two cells that are sharing an edge. So, for example, if this were a 3, this would have to be 7, because these two digits must add up to 10, because X separates them, and that's what it means. Similarly, if this were, say, F1, this would have to be a 4, because these two digits must add up to 5. But you cannot have you can't have a random 1 and 4 here, for example, because those add up to 5, but we are told that all possible X's and V's are already marked. So therefore, this is not possible then to have it here. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's go. Okay. So everything that's next to a V has to be 1 through 4. So these are all 1 through 4. This is 1 through 4. This has to be 6 through 9 to add up to 10 with this digit. These are all 1 through 4. This must be 6 through 9, and this has to be 1 through 4. This is 1 through 4, this is 1 through 4, and this is 6 through 9 here. These are all 1 through 4. These are 1 through 4. This has to be 6 through 9. These are 1 through 4. We don't know about this. We don't know about this, and we don't know about this. This has to be 6 through 9. Okay. And these are all the V's and X's we have, right? So this has to be the same as this one, because it adds up with this digit to be 5. We don't know about these. This digit has to be the same as this, which must be the same as this. So these, let's make this actually orange. This has to be the same as this. We don't know about this, right? There doesn't have to be a constraint of no repeats in outside the grid. Huh. What's interesting, though, is anytime you have an x here, or like, yeah, if you have an x here, right? Say this is 1. This would be 9. Obviously, that works. If this is 2, that means this has to be 8, and then you see a 9 afterward. Okay, I guess that always works. What happens if it's 6 through 9, though, is the question, right? So say this was a 6 here, and this would see 1, right? If this is 6 and this is 4, that means you would have to see everything in order. So it would have to be 4, 5, 6, 7, 8, 9, all in order. So if you see 9, it would be obviously 1, then 2, 3, 4, 5, 6, 7, 8, 9. So one thing is, we know none of these can be 9 that do not have an X next to it. And they can't be 1 either if they don't have an X next to it, right? Oh, that's interesting. Right. If this is 1, this would have to have a 9 next to it, which would force that to have an X. So this cannot be 1. This cannot be 1 because of a similar thing, right? This can't be 1 because then there would be 4, and there it would seem more than 4. So this can't be 1. This can't be 9 then, which means that can't be 4. This can't be 1 because it would have to have a 9 next to it, and it would not see it. So this can't be 1 either, similarly, because this would have a 9 next to it, but it can't see that. So neither of these are 1. Therefore, they're both 2 and 3. This is 2 and 3. This does not have a 9 next to it, so this can't be a 1. This can't be a 1 again, because, so therefore this is 2 and 3, which means this is 2 and 3. This has to be 6 and 8. This is 6 and 8, which makes this 2 and 3. This is 2 and 3. This does potentially have a 1 next to it, so this can't be 1. But this can't be 4. This can't be 6. So this could be 1 and 9 here. And this could be 1 and 9. But these can't be 1 and 9. So these have to be 2 and 3 here. Similarly, these can't be 1 and 4. So this has to be 2 or 3. These could be 1 and 9, or 9 and 1 also. Well, this cannot be 9 here. It could be 1 and 9, but this can't be 9 here. Because if this were 9, this would see 9 here, and then would not be able to see anything else. So this sees 2 or 3, this sees 2 or 3, this sees 2 or 3. This, this sees 7 or 8. That's kind of crazy. So if this is C7, it cannot have a 4 or above in this square, right? If this was 4, it would only see 6 skyscrapers here. And this is not allowed because this is 7 or 8. So this has to be 1, 2, or 3. Well, we have a 2, 3, 2, 3 pair in column 1, which eliminates 2 and 3 from the rest of the column. Therefore, this must be a 1. We can see 1 of 2 or 3 here. Or it could just be 4, 5, 6, 7, 8, 9, right? We see 2 or 3 here, so this cannot be 9. If this were 8, this would see 2, but then that's not allowed, so this can't be 8 either here. It could be 7. So this could be a wide variety. It could be 2 through 7, right? So it's C, this C is at least here and here. So if this is 2, this would have to be 3, which would force this to be 2. But this is 7 or 8. So it cannot... Oh, no, it would have to be 9 here, which would be 1. Which is possible, actually. So if this is 2, this is 3, and that's 9. That's possible. If this is 3, this is 2. So this could not be 9. But then it would see 3 digits here. So say this was a 2. Sorry, say this was a 3. This would have to be 2. This has to be greater than 2, so it would see that one. I guess it could be 8, and then this is 7. And then this is 9. So that's possible still. Unlikely, but possible. Right, so then this would be 8, that would be 7. So if this is 2, this has to be 3, and then it has to immediately see a 9, because otherwise it would see this cell. I guess it could be 8 or 9. No, it has to be 9 immediately, which would mean this sees 1. Otherwise, this is 2. Sorry, this is 3. It sees 2. It would obviously see whatever this is, which would have to be 8, because this would be 7. So then this would be 8. So this is specifically 1 and 2, and it sees 8 or 9 here. Huh. This could see 6. So this is 1 through 4, right? If this is 6, oh wait, no. If this was 4, well, it could be 4. No. If it's 4, it can only see 6 at most, and therefore this would have to be 6, which is not possible. So this can't be 4. Therefore, we have a 1, 2, 3 triplet, actually, in row 1, which eliminates 1, 2, and 3 from the rest of the row. So this is 4 through 9. This is 4 through 9. Obviously, these can't be 9 because they see at least 2 digits. So neither of these can be 9 here. This can't be 5, so this has to be 1, 2, 3, 4, or 6. Well, cannot see these two, and it can't see that one. So that's 3 cells that it can't see, but it could be 6, 4, 5, 6, 7, 8, 9. That's possible. This can't be 9 either. None of these can be... the 9 can only be next to a 1 if it's on the edge. And therefore it has to be an X. So either this is 9, 1, this is 9, 1, or this is 9. And this can't be 9 or 1. So if this were 9, this would have to be 1. If this were 9, this would have to be 1. And there would have to be an X in both of them. So this cannot be an X. This has to be a 9 then. This is a 9, this is a 1. Which makes this C2. So this is 2. These are 3. This is 7. This is 3. Either this is 1, 9 or this is 1, 9. We're not sure which. So one of these two is a 9, one of these is a 9, and one of these two. This can't be a 9. So this cannot be 9, which means this can't be 1. These can't be 3, so this can't be 2. This can't be 8. So this has to be a 9. Oh, wait, no. The 9 could be here also. So this could be 9 or that could be 9. This sees 7. So whatever digit's here, it will not see a 3. So it could be 2 here. This sees 3. We know this can't be 2. And then therefore this can't be 3, because this would have to have a V between them. Hmm. Hmm. This is at most 4. So this is 2 or 4. This is at most 5. This is at most 6, at most 7, at most 8, and at most 9. So this could be at most 9 this way too. Hmm. One thing is, I mean, it could be 2 and 8 here. This can't be 9. Um, These cannot be 8. If this is 8 or this is 8, that would mean this would be 2, guaranteed. But since neither of these have an x next to them, neither of these can be 8. This could be 8. This could be 2 with 7, right? This sees 3. So this is specifically 2, 4, and 5. This is 2, 3, 4, 5, 6. This is 2 through 7, 2 through 8. We know the 9 has to be one of these two then, which means the 9 has to be one of these 3 somewhere here. This cannot be 9 because it cannot see 3 then, so this can't be 9. One of these is a 9, which means one of these is a 2, but we already knew that. This cannot be 9 because it can't see 6 skyscrapers then. So this can't be 9, which means this has to be a 9. This could be any 2 through 8 here. So that's fine. If this is 8, it would not see 6. So this cannot be 8. This can't be 7. This can't be 6. It could be 5 because that could see... Actually, it could be 6. It can't be 8, though. So this can be 1 through... It sees at least 4 others. So this has to be 1 through 5. This could be 6. So this has to be 8, then. This has to be 8. This is shorter than it. This has to be... This could be a 7 here. We're not sure. This then sees 2. This has to see 3. So this cannot be a 3 because then they would add up to 5 and there would be a V here. These can't be 2. This can't be 2 because that would add up to 10. This can't be 2 because that would add up to 10. One of these is 9. We're not sure which. 8 cannot be here. This can't be 9. This sees 2. This can't be 8. So it could be 2, 4, 5, 6, or 7. These obviously can't be 9. But they could be up to 8. That's fine. This cannot be 8. But it could be 1 through 7. This is 2. We don't know about this. This could be through 8. But the 9 is obviously there. This can't be 4. If this is 4, this would have to be a V. So this must be 2. None of these can be 2. This can't be 2 anymore. None of these can be 2. So this is at least 4 through 7. The 6 has to be one of these 3 because this is 4, 5. This has to be steadily increasing because this one is not seen. So it sees 1, 2, 3, 4, 5, 6, 7. So this has to be greater than 3 or 4. This has to be greater than, this is, yeah. So 3 cannot be here because that would add up to 5. So this must be a 3, which means this can't be 3. This can't be 3 either. Hmm. This is at least 2. This can't be 8. This is 7 or 9. This cannot be 8 because then this would add up to 10. This would have to be a 2 and adds up to 10. Oh. Yeah, where is the 8 in this column? Anytime you have an 8 here, it has to be next to a 2 because that will always see 2 there. Therefore, this can't be 8 anymore because this can't be 2. So this must be 8, which makes this a 2 and this a 2. Therefore, this is the only place for 9 now, so this is 9, 1, and 4. The 8 cannot be anywhere else here, so 9 has to be one of these. 8 has to be one of these 3 also. 7 doesn't, though. It could be 7 straight to 9, right? Anytime you have an 8, though, you also have to have B straight through 9. So this is 4 through 7. This is 8. It sees 2, specifically the 8 and the 9. We're not sure about that. So the 8 also has to be one of these 3. Hmm. 4 cannot be next to 6, so this can't be 6. This can't be 1. This can't be 3. Or 8. This can't be 2. No. If this was 6, this would have to be 5, because it can't be 4 and 6, because that would add up to 10, but there's no x between them. So if this is 6, it has to be 5. If this is 5, it has to be 4. So if this is 6, this is 5. If this is 5, this is 4. Either way, there can't be a 5 here. This cannot be 2, because then this would add up to 5. This can't be 7, because this would add up to 10, and there's nothing there. This can't be 2, because if this were 2, this would add up to 5, so this can't be 8. So we know this is 8 and 9 pair here. Okay, so this is 8 and 9. This is 8 and 9, because those are the only two possibilities here. Because that is the only possible place where 8 and 9 can be. So this can't be 1 or 2. This is 3 or 4. So these are obviously different ones. Okay. This cannot be 2. If this were 2, this would be 3. And then you would see definitely something that's greater than 3 in one of these 5 cells, and then you would see 9. So this cannot be 2. It has to be 3, which makes that a 2. Which makes this a 2. This can't be 8. That's actually very interesting. These see at most 6, right? Because it could be 4, 5, 6, 7, 8, and 9. But this can't be, so this can't be 1 because it's next to a 4 and there's no V between them. It could be 2, could be 3, could be 4, and could be 5, but no 6 is allowed here. This cannot be, this could be 1. Actually, it can't be 1 because it would have to be 9. This sees 1, 2, and 3. So this is a 3. This is always greater than this. So that's, oh, you'll see both of these and then see this. This cannot be 1. It could be 2. It cannot be 3 because then this would have to add up to 5. And there's no V there. This could be 4. This could be 5. It could be 6 here. Because it could be 4 through 9 here. This sees 4, but we don't know how many or what they are. This can't be 2 or 1. It could be 3. Oh, it can't be 2 or 1. If this were 2, this would have to be 9. But since it cannot be 2, this always has to be 8. So this is 8, this is 2, this is 1, this is 4, this is 9. So it has to see 3. So this sees 3. Interesting. This can't be 7 anymore then. Because it sees 4 digits. So this is 4 or 5. This can't be... So far, this could actually be a lot of things. So it could be 1, 2, 3, 4, 5, and 6. So this could be up to 6. So it could be 1, 2. Cannot be 3 because this would add up to 5. So this is 4, 5, or 6. This cannot be 9 because then this would have to be 10. It could be 8, 7, 6, 5, no 4. Or it could be 2 or 3 here. This cannot be 2 or 3. Actually, it could be 2. Can't be... Could be 1 or 2. This cannot be 4 either way. Because it can't be 9 either. Oh, all the 9s always have to add up with 1, right? So this can't be 4 or 9 or 1. This sees 3 at most. So this is 2 or 3. This could be 1 or 2. Cannot be 3. Could be 4. Cannot be 5. Could be 6, 7. Oh, it could be 5. This actually could be 5. Oh, this could be 5 also. Interesting. This could not be because it's 1 through 4. But this actually, these x's could be 5. But the problem is we needed a 9 and an 8. And this could not be 8. Because that would have to be 2. And therefore this would add up to 5. And there's no v there. This cannot be 3, obviously. This can't be 2, it can't be 3 or 8, can't be 1. It could be 2. 2, 4, 5, 6, 7. So this could be 3, 4, 5, 6, 8, or 9, but it can't be 8 here, so this can't be 2. Similarly, well, this one's a broader range because it's not limited by any other digit here. This can't be 4 because this would add up to 5, and that's not signified by that. This can't be 8 because that would add up to 10. So one of these two is 8 here. So this can't be 8. One of these two is an 8. This cannot be 8 because then this would not see 4 skyscrapers. So this can't be 8. This has to be an 8 then. So this sees at least 3 here. So this can't be 2. Hmm. 9 has to be one of these 3 here. None of these can be 8, which means this cannot be 8 because then one of these 2 cells is definitely larger than 2. And it would see that, then it would see 8, and then it would see 9. So this cannot be 8. One of these could be 8. So this can't be 8. But this one or this can be 8. This can't be 8 again because the 9 would not be in front of it. The 9 has to be one of those 2. It's one of those 3. It's one of those 2. So you could see 3 here. Therefore, it could see 3 in the rest. So this is up to 7. This is up to 8. This cannot be 9. So 9 has to be one of these 3. But this can't be 9 because this sees 2. So one of these 2 is a 9. So this can't be 8, actually. So this could be up to 8. This cannot be 8. If this were 8, we know one of these digits is greater than 2. So it's C4 here. So this can't be 8. None of these can be 8 either. So the 8 can't be here. Where is the 8 in box 6? Can't be here, can't be here, can't be either of these because of the way this skyscraper reacts. Can't be here because of the way this skyscraper reacts. So therefore this must be an 8 here, which means neither of these are an 8. Since neither of these are an 8, where's the 8 in box 5? It has to be here, which forces this to be 9. So this can't be, this is 9, which means this can't be 9. So this must be a 9 here. So this sees 2, which makes this 3, which makes this 2, which makes this an 8. So this can't be 8. This sees 3. Okay, which means this can't be 9. Where's the 9 in this column? It can only be here. So this is 9, this is 1. This cannot be 2, 8. It cannot be 1, 9. This can see at most 6. So this could be 6, 5, 4, 3, but no 2. So then this would see 7, 6, 5, or 4 here. This sees more than 1. So this can't be 1. This could be 2. It cannot be 6. It cannot be 5. This is 2 or 4. Okay, this cannot see 7. It can see at most 6. It cannot be 2. So it has to be at least 4, 5, or 6. Because it sees at most 6 here. This cannot see one of these, but we don't know which. So this is 8. This can't be 9, so 9 has to be one of these two. We have a 4, 5, 6, 7 quadruple in box 2. So that eliminates 4, 5, 6, and 7 from the rest of the box. This has to be 1, 2, or 3. This is 1, 2, or 3. This will never see this one. So it has to see this one, and it has to see this one. So it cannot be 6 or 7. This is 4, 5. This is 4, 5, or 6. This can't be 3, because then this would have a V in between them, so this must be 4. So this is 4, this is 1, this is 2. This has to be 6. This can't be 2. This can't be 1, this can't be 1. So it sees these 3, which is fine, and then 9, which is fine. This sees 2, that's fine. This sees 3, because so therefore it sees both of these. If it's 3 and 7, it's fine. This can't be 8. What does it see here? This is... It cannot be 1. It could be 2 through 6. We're not sure which. This cannot be 4. It cannot be 9, obviously. It sees those two, so it's at least 3. Cannot be 4. Could be 5, 6, or 7. It sees 1, 2, 3, 4, 5, 6, 7 at most. The 9 has to be one of these 3, so this is either 2 or 3. This sees 1, 2, 3, 4, 5, 6 at most, so it could be 6, 5, 4, no 3. It could be a 2 here. We're not sure. Okay. If this were a 6, it would have to be next to a 4 in one of these spaces, so it cannot be 6 here. One of these is a 4, so this can't, because this can't be 4. So therefore these cannot be 4, which means this can't be 6. What else? This sees an 8. That's interesting. So this is essentially done. This is done. This is done. This is done. This still has some leeway there. This is kind of done. This is still has some things we need to figure out. This is done. This has a lot of stuff we need to figure out. This has a lot of stuff. Same here. This is done. This is done. We don't know about this. Oh, this cannot be 2. It has to be at least 4, 5, and 6 because one of these, at least one of these is less than 8, right? So this is done. This is done. This isn't done, but we're kind of restricted. This is done. This is a lot to go. This has a lot to go. This is done. This is essentially done. This is done. This has a while to fix. This is 3, so this is actually pretty limited here too. Oh, where is the 8 in this box? It has to be here. So this is an 8. And we have 8 8s, so now we know where the last one is. It has to be here. So this is an 8. This cannot be 9 because this sees 4. And this would be only C3 if this were a 9. So this can't be 9. This is a 9, which means this can't be 9. So this is a 9. So this could see at most 2 or 3. This sees 2. That's fine. Sees 4. Do we have all the 9s? 1, 2, 3, 4, 5, 6. Yeah, we have all the 9s. We have all the 8s. I don't even know if we have all the 2s though. Oh, this has to be a 2 because of what's left. This can't be 2, so this is 2. So 2 has to be one of these 2. 2 has to be one of these 2. I don't know if we don't have many 3s left. 3 cannot be any of these 3 cells because it would be next to a 2. So the 3 has to be one of these 3. These can't be 3. This can't be 3. This can't be 8. This can't be 3 anymore either because this would be 2, 8, and 9. We know there's lots of variables that or digits that could be here. So this can't be 3. It could be 5, 6, or 7. This can't be 3. This can't be 3. Where is a 3 in column? Like this can't be 3. Where's a 3 in column 9? It has to be here. So this is a 3. This can't be 3. The remaining digits are 1, 4, 5, 6, 7. This is 1, 4, 5, 6, 7. This can't be 7 because it cannot be 1, 2, or 3. Why can't it be 2? Oh, because it has to see at least those 2, right? And it can't be 3. So this could be 1, 4, 5, or 6. This then sees 3 because this is an 8. And it will see all 3 of these skyscrapers. So this is 3. This can't be 2. So it has to be at least 3. It could see only 5, 6, 7, 9. So this is 4 or 3 here. This is 8. The 2, where can the 2 be? 2 cannot be here. because that would add up to 10. So this must be 2. 2 cannot be here or here or here or here. So this must be 2, which makes this a 3. This is a 2. One of these is a 1. I'm not sure which. Twos are all set. Ones are kind of limited, actually. Where could the 1 be? 1 cannot be here. 1 cannot be here. 1 could be any of these 4 so far. What about 3s? 3 could be here or here. Cannot be here because that would be next to the 2. This can't be 7 because that would add up to 10 with both of these. So this is 5 or 6. If this were 5, this would have to be 4, which would force this to be the 6 because that's the only place possible. Because we tried to have the 6 here, and that's next to 2 4s, if that's the case, which would be given 10. So if this is 5, this would be 4, this would be 6, this would be 7, and it would see more than 3 skyscrapers. It would see 4. So this can't be 5. This has to be a 6, which means neither of these can be 6. So this can't be 6. This can't be 4. So 4 has to be one of these 2. That's interesting. This could be 1, 2, 9, in which case that would see 3. This can't be 6, because if this were 6, it would be next to a 4, definitely. And that's not allowed, because there's no x between them. So 6 has to be one of these 2, which means this can't be 6. This is 4 or 7. Three is one of these 2. One cannot be here. One could be here or here, specifically. This sees both of these 2. It must see one of these, and then it sees that one, obviously. This sees one of these. It sees this one, and it sees here. The remaining digits here are 4, 5, 6, and 7. Three is one of these 3. That doesn't really tell us much. Oh, wait, no. 3 can't be next to the 2, so this has to be the 3. 3 can't be next to the 2 here, so 3 has to be one of these 3. 7 cannot be either of these because it would add up to 10. So 7 has to be one of these 3, which means this can't be a 7. Can this be 1? It could. So this is 1, 4, 5, 6. I'm not sure which. The remaining digits here. This can't be 7 because that would add up to 10. So this is specifically 5 or 6. Um, hmm. If this were 1 and this were 5, this would have to be 6 and 7, which would force that to be 4, which would add up to 5. So this can never be 5. This has to be 1 or 4. This can't be 6, actually. Hmm. This is 1, 4, 5, 6, 7, but these can't be 1 because of they would be next to a 9. This can't be 1. It's kind of not that limited. This is 1, 4, 5, 6, 7. Sees that one, it sees that one. Hmm. This could be 1, 2. In which case that would see 4. Where can 3 be? 3 could be here or here. This cannot be 3, though. This can't be 3. 3 has to be one of these two. This can't be 3. One of these two is a 3. Because neither of these can be 3. And this can't be 3, so this must be the 3 then. Which means this can't be 3. This can't be 3. This can't be 3. This can't be 3. This has to be the 3. And we have all... Well, we don't have all the 3s. Um... One of these is a 7. If this is 7, that would only see 2 cells, so that's not possible because that would add up to 5. Therefore, this can't be 7. Therefore, this has to be a 7. They have a 5, 6, 5, 6 pair in row 1, which eliminates 5 and 6 from the rest of the row. This must be 4. This must be 7, which makes that 6, which makes that 5, which makes that 4. This can't be 4. One of these is 5 or 7. We don't know which. This can't be 5. So this has to be 4 or 5, and this is 5 or 6. If it's 4, it sees 6, 7, 8, 9. That's fine. If it's 5, it sees 5, 6, 7, 8, 9, which is also fine. This sees 5 or 6 is greater than 1 or 4, but it only sees 3, so this is 3. It sees this one, and that 9. This can't be 4. So one of these 3 is a 4. One of these 4 is a 4. 1 can't be here, so 1 is one of these 2. 1 cannot be here, So 1 is one of these two. And 1 can't be any of these, so 1 is one of these two. This can't be 1, so any of these 5 are 1. Any of these 4 is a 1. 4 has to be one of these 3. This is 1 through 7. But this can't be 7. This can't be 6. This can't be 6. So this is 1, 4, and 5. This can't be 1. This is 4, 5. This sees at most 4. So it could be 3 or 4, which means this is 6 or 7. Right? Because the 8 is here. So it sees 8 and 9, and it could see either of these. No 4 or 5, so it's 1, 6. So this is 1, 6, or 7. It can't be 7 here. We have a 1, 6, 1, 6 pair in column 4, which eliminates 1 and 6 from the rest of the column. So this must be 7, which makes this 3. This can't be 2 anymore, so this has to be 3. This can't be 7, because otherwise there would be an X in between them. So this sees 3, which makes this a 1. So this can't be 1. This can't be 1. Since this is not 1, it only sees 2. It cannot receive 4, so this has to be 2. So this has to be greater than this one. So this cannot be 4, and this can't be 7. Well, it can't be 7 anyways, so this is 5 or 6, which makes that 4 or 5. We have a 4, 5, 4, 5 pair in column 9, which eliminates 4 and 5 from the rest of the column. So this is 6, which makes that 5. That's 5. This is 6. This can't be 5 or 6, so this is 1 or 4. None of these can be 6. This is the only place for 1, so that's a 1. This can't be 1, so therefore that's a 1. This has to be 6 then, which forces this to be 1. 6 cannot be any of these spaces. This can't be 1. This has to be 6 now because of the 4, 5, 4, 5 pair in box 8. We have a 4, 5, 7 triplet also in row 7, which makes this a 6. This sees 4. We see a 3. We will see one of these two, as long as this is not 4. If this is 4, this would be 5, so this can't be 4. We see this one. If this is 4, we would have a 7 definitely guaranteed here. So that would see 4 digits, so this can't be 4. If this is a 5, we would have a 7 definitely guaranteed behind there, so this can't be 5. This is 7, which makes that a 5. Which makes that 4, which makes that 7. This sees only 2, so this is 2. This cannot be 7. This has to be 4, 5. This is 4, 5. This can't be 4 because this would add up to 10, and there's no x between them. So this is 5, this is 4. This sees specifically 4, 5, 6, and 9. So this is 4. This can't be 4, so this is 5. So 4 is one of these two. This can't be 5, so this is 7, which makes that a 5. It's interesting what the remaining digits have to be. This sees 3, 5, and 6. It cannot have a 7. It sees an 8, and then it sees a 9. So this is sees 5. This would see 3. Well, this has to be 5. This is 4. This sees 4, 9. This is 1. That makes this 4, which makes that a 1. This cannot be 1, 4, or 5. So this is a 6, 7 pair. This sees specifically 5, 8, and 9. So therefore this is 3. This has to be 3, 4, and 5 here. And this can't be 3. This can't be 4 because this would add up to 5 without a V. This can't be 5. So this is 3 or 4 here. This can't be 5. We know there's a 1 here, so this has to be a 1. The remaining digit is 4, so this is 4. This can't be 4. Remaining digits here are 3, 6, and 7. But this one has to be not seen because we see these 2 already in the 9. So this has to be a 3, which makes this a 5, which makes this 4, which makes that 3. That makes that 7. This is 6. This is 7. This now must be 4. This is a 5. This can't be 3 or 7, so this is 6. This has to be 7, but we want to finish off the skyscraper. So this sees actually 6. This sees 2, 4, 7, 8, 9. So this sees 5. And this must be a 7. And congrats, we solved the puzzle. I never felt really stuck here, actually. Obviously, the key was figuring out that it was really the XV negative constraint, right? Because that limited where the 9s and 8s could be on the borders. And it limited a whole bunch of other stuff throughout the grid, right? Pretty cool puzzle, and I hope you had a cool time watching me solve it, and I'll see you next time on Frank Puzzles. Take care.